Section 3 is kind of confusing.
Like section 3 is like kind of the keystone concepts too. Like it's our capstone, you can almost say, when it comes to college algebra. There she is. We hadn't started yet, so it's perfect. You guys are going to get a personal lecture because I don't think anyone's online. That'll be fun. I guess I'm recording right now. Okay, so before we get started, today is election day. Go vote. If you're watching this tomorrow, why did you forget to vote? I need to talk a minute about the final. So the final is different than the regular test that we're taking, and I need to let you know before we get there. So yeah, it's about a month from now. So the final, we have a common college algebra final each semester. The same with the intermediate and beginning, the other algebra classes. It's December 4th. It's Dead Day, okay, or Study Day, I think is what we call it. There's no other classes. It's a Friday. Now look, I'm gonna give the test exactly as I've given it before in here, where I'll put it in Blackboard. You can take it whenever you want to. It just has to be done that Friday, okay? Has to be done. Now, if it'll be online, you get two and a half hours to do it instead of the hour and 15 minutes. If there's no way at all, there's no possibility of you taking it Friday, just get with me and we can try to work something out. It's just something that we've got to do because we have to get grades in by that like Saturday, actually. It's kind of weird with college algebra. But so December 4th, Friday, is the final. I'll talk more about it, of course, that week leading up to it. But I want to let you know now, in case, if you, for some reason, work 18 hours a day on Friday or something of that nature, get with me and we'll work something out to move it around. It won't be a big deal. Okay, so let's keep moving on. So today we're going to go over section 3.3, which kind of feels like a left-hand turn at first, but then it goes into the flow of 3.2 from before. So 3.3 is on division of polynomials. We've got to divide up polynomials to find all their factors, okay? So I'm going to stick to synthetic division, but before we even get there, let's go over some basic division from third grade, okay? So let's travel back to third grade and talk about how we divided numbers into other numbers back then. So let's say we had a number that divided evenly. Let's say we had something like 32 divided by 4, okay? Now, we originally wrote it as 32 divided by 4, right? There's two different ways to write this, and they'll pop up today in this section with polynomials as well. But to do this, to do 32 divided by 4, you probably did this whole thing, right? So how many times does 4 go into 32? It doesn't go into 3, right? And then it goes to 32. Oh, it goes 8 times, right? 8 times 2. We divide it out, and we got a 0. Now, because we got a 0 here, it meant that the 4 divided evenly into the 32, right? And when you do that, you wind up with 8. So let's talk a little bit about terminology, because this terminology is going to be true for the polynomials as well. This is called our quotient. This is called the dividend. This is called the divisor. And this is our remainder, right? And we wanted a remainder of 0. Remainder of 0 meant that it divided evenly into, or the divisor really divided evenly into the dividend. And so 32 divided by 4 was equal to 8, okay? And now for today at first, that's going to be our answer. You're going to divide polynomials. It won't be numbers, it'll be polynomials. And we'll get some answer and we'll box it in. But moving forward, what's more important, so over here, if 32 divided by 4 equals 8, for us, because our goal is going to be to get this 32 factored. If you multiply the 4 over, this means that actually 32 is equal to 8 times 4. We're breaking down the dividend, okay? And we're going to do that. That's really what's more important moving forward into at the end of 3.3 today, but then all of 3.4, okay? We're going to be breaking down dividends. And really what dividends are going to wind up being are polynomials, long polynomials. And our goal is to break these down into different factors, okay? Okay, so let's do one that didn't divide evenly to show how we wrote it and how we wrote it maybe in 3rd grade and then how we wrote it in 4th grade. Let's do a big one. So we had like 414 and we want to divide it by 3, okay? Actually, this is going to divide nicely. Let's not do that one. I didn't mean to do that. Let's do 416 divided by 3, okay? 416 divided by 3. We're going to put the 3 out here and the 416. We said 3 goes into 4 once. Subtract it, we get a 1. Bring down the 1. 3 goes into 11 3 times. You might have done this differently. It doesn't matter. I don't care how you do it. And then we brought down the 6. 3 goes into 26. How many times? 8 times? 8 times 3 is 24. Now we've got nothing to bring down, so this winds up being our remainder. So because it's not 0, it means that that 3 does not divide evenly into 416. Look, this isn't going to help us along the way for breaking down 416 because 3 turns out not to be a factor of 416. But for this section, we've got to learn how to notate it properly. Okay, so to notate this one, the way we're going to do this in this section is that, well, 416 divided by 3 is going to be your divisor, your quotient, plus the remainder over the divisor, okay? Now, back in 3rd grade, you probably said something like 138 R2, right? You guys remember writing it like that? Yeah. Now, that was just saying 138 remainder 2 because the remainder was here. But really what's going on is you've got 138 plus 2/3. You're almost at another 1, right? And we'll only need one more 1/3 to get to 1, but there's this remainder of 2/3. So today, whenever we wind up with the remainder, to write the answer, it's going to be quotient plus remainder over divisor. I'll tell you though, this just doesn't help us out in the long run, okay? This doesn't help us get to our goal of really, again, our goal is going to be breaking down this dividend, okay? This didn't break it down at all because we had a remainder. The remainders are no good for what we are trying to do. Okay, so let's keep moving on. Let's actually get to it. So your book goes over 2 ways of dividing, and I am not worried about the first way of dividing because the second way does the job better, quicker, and it's really kind of more appropriate for what we're doing with finding zeros is what this all leads to. So I'm going to go over synthetic division. Well, synthetic division of polynomials. Okay, synthetic division of polynomials. If we're going to do synthetic division of polynomials, there's a few rules about the polynomial. One, they must be written in descending order with missing terms. And we talked about that last lecture. We'll see it again in this lecture. Written in descending order with missing terms. And there's a rule about the divisor. The divisor must be x plus a or x minus a, where a is going to be important actually, but x plus a or x minus a, I think they write it as a, I say b. It doesn't really matter what the letter is, but just realize the divisor must be written as x plus a number or x minus a number. It can't be 2x or 4x or 5x plus a. It's got to be x plus or minus a. And so let's do this. Let's do one. Actually, I'll steal one from the book. Yeah, let's do one that works nicely. Maybe at first. Hold on. hold on. The book's got a lot of ones that don't work nice. Yep, okay, we'll do a basic one. Let's say we've got x squared plus 10x plus 21. I'm just stealing this one straight from the book. It says divide x squared plus 10x plus 21 by x plus 3. Okay, notice that this is going to be our dividend, and it's written in descending order. There's no missing terms. We got x squared, 10x, and 21, right? There's no missing terms, and it's in descending order. And then the divisor is x plus a number, right? X plus a number. So it works for both of these rules. So we're good to go. And now, if you've never seen this before, have you guys seen this before? It's weird. Have you seen this before? Okay, so pay attention here. So you draw a little L, like a little bracket kind of thing. Okay, that's step one. And I'll tell you what this really comes from is checking for zeros. And remember at the end of last lecture, if x plus 3 was a factor and we solved it, the solution was -3. Okay, so x plus 3, whatever you get here, x plus 3, you're going to change the sign of this constant and put it right there. Okay, and then we're going to write the coefficients of the polynomial descendingly right here. So x squared, the coefficient's 1. 10x, the coefficient is 10. 21, the coefficient is 21. You got to set it up properly if we're going to do this one properly. Okay? And then it does feel like we're just going to wave a magic wand, but that's just part of it. So the first thing you're going to do is bring down the 1. Always bring down what's here. It comes down first. And then once it gets below the line, you multiply it by, and I'll tell you, this is called a potential zero. Okay? That's the best way to think of it. Multiply it by the potential zero. So 1 times -3, that's -3. And you put it right there. Okay? Once it gets below the line, multiply it by the potential zero and then put it right here. And then you add vertically. 10 plus a -3, oh, that's a +7. Okay? And then again, once it gets below the line, you multiply it by the potential zero. 7 times -3, -21. We add vertically. Hey, this is a good thing because that whatever we get on the far right is our remainder. We got a remainder of 0. What this means is this divisor divides evenly into this dividend. Okay, this divisor divides evenly into this dividend, which is kind of neat. But what's the actual quotient, right? What do we get when we divide? It's actually in the numbers to the left here. Okay, and now I guess instead of ascending, we go or descending, we go ascending from the left. So if this is the remainder, whatever's next to the remainder is the constant. And whatever's next to the constant is the x term. And if it kept going, we'd have an x squared term, an x cubed term. And we'll see examples of that like today, okay? So remainder constant x. So really what we have here is the quotient would be 1x plus 7, okay? And I know we don't write the 1. I just wanted to show you where that's coming from. There's the 1 and there's the 7. So it's just x. Actually, check this smoothness out. X plus 7, okay? That winds up being our quotient. Now, there's no remainder, so we don't have to deal with the remainder issue. We'll do that on the next one, okay? But we don't have to deal with the remainder issue on this one. Questions? Okay, it's just a pattern. It's one of those nice things if you're like, man, I like just learning something new and doing it over and over and over and over again. That's what synthetic division is. But I really need you to grasp what it's telling us, though. Look, that remainder is what really matters. It tells us, okay, let's dig a little bit deeper here to show you what I wrote earlier with numbers, like with that 32 divided by 4, it equaled 8. Well, what this tells us is that x squared plus 10x plus 21 divided by x plus 3 gives me x plus 7, okay? But what's more important, if I multiply this over, I know that x squared plus 10x plus 21 is just x plus 7 times x plus 3. It broke down it broke down our dividend, okay? And that's all due to the fact that we have a remainder of 0. Okay. If we did not have a remainder of 0, we couldn't go this far. We'd be done. We'll do an example of one with the remainder of 0 next. Or not a remainder of 0, I should say. Next. Okay. Let's look at another one. There's some crazy stuff up here. Getting wild and woolly. Okay. This is kind of a weird one, but follow along here. We've got 7 minus 11x minus 3x squared plus 2x cubed. And we're going to divide this by x minus 3. Okay. Now, first off, look, notice this dividend is not in descending order. We've got to write this in descending order. I don't think it has missing terms because you got a cubed, a squared, an x, and a constant. It's just written ascending and not descending. So let's write this descendingly first. So 2x cubed minus 3x squared minus 11x plus 7. I'm going to divide that by x minus 3. Okay? And now I want you, actually, let's do one more, and then I'll kind of see if you can do these on your own. Which, if you want to start trying to do this on your own, that's fine. So remember, if it's x minus 3, we're going to do if x minus 3 is the factor, we're going to do the potential 0 here. So that's going to be a positive 3, okay? You got to change the sign. Minus 3, positive 3. Then I'm going to write descendingly these coefficients. 2, negative 3, negative 11, and 7. Okay. Okay. So let's do the process. Bring down the 2, multiply by the 3, I get 6. Add, I get 3, multiply by the 3, I get 9. Add, I get negative 2, multiply by the 3, I get negative 6. Add, I get a positive 1. This is not a 0. And we need it to be a 0 if this divided evenly, okay? But it's not a 0. It's a bummer, okay? And I'll tell you, in the next section, if this isn't a 0, we're just going to go about our merry way and try to find terms that do give us a remainder of 0. But to actually answer this question now, we have to think of, if one's a remainder, how do I write this? So we actually write it, now the quotient's here, 2x, look, this is negative 2, 3x, and 2x squared. Okay, remember we go ascending. So remainder, constant, x squared now. If there was another one, it would be x cubed. So it's going to be 2x squared plus 3x minus 2. And then remember, it's plus the remainder over the divisor. Remainder over the divisor. Okay? Questions? It's goofy, and to me, synthetic division feels like you're just waving a magic wand and you get the answer. Okay? It's like you're waving a little magic math wand and poof, there's the answer. And it's a bummer it's like that, but I'll tell you the long division way, honestly, long division is the same way. I mean, no one ever sits back and goes, why in the world do we do this long division? It's really goofy. It doesn't tell us anything. It doesn't tell us anything about placeholding. It doesn't tell us anything about actually like big math issues. So it's the same thing. This is just a lot shorter. Okay. So I'm going to give you a few of these and I want you to try them on your own to see if we've got this down. And I'm going to steal some from the book. Okay, this is number 4 on page 373. X cubed minus 2x squared minus 5x plus 6. We're going to divide that by, x minus 3 again. Didn't mean to choose that x minus 3. Let's do one that's not x minus 3. Let's do, let's do 22. Yeah, it's not x minus 3. 22, 5x cubed minus 6x squared plus 3x plus 11. And we want to divide that by x minus 2. Okay, try those two. I'll give you a minute. Try those two. Okay, I'm gonna start these. Let's see. 3, right? If it's minus 3, you got to plus 3. 1, negative 2, negative 5, and 6. And notice they're all there. I need to do one with a missing term. We haven't done one of those yet. Neither one of these have a missing term. So bring down the 1, 3, 1, 3, negative 2, negative 6, 0. Hey, that's a good thing, right? And what this tells me is that we wind up with now this is constant x squared. So x squared plus x minus 2. Bingo, bango. Got it? Okay. So then now let's see about the other one. So we're going to have to put a 2 here. 5, negative 6, 3, and 11. So constant x squared. So 1x squared, 1x minus 2. Yeah, it's right there. And it really is descending, but this is always your remainder. Okay. So remainder, that's why I kind of boxed it anyway. That actually tells us the most about the division. So I'll box in the remainder, and then this is the coefficients to your quotient. So we get 5. 2 times 5 is 10. 4, 8, 11, 22, 3. I got 33. I can tell you if that's right or wrong. It's right. So not good. We got a remainder, but how do we write that? So this is our remainder, constant x squared. So 5x squared plus 4x plus 11 plus, now remember, it's remainder over divisor. That's a 2. Horribly written 2. Okay? And again, this doesn't tell us anything. This is no good. Look, frowny face, okay? No good. This, happy face, okay? Happy face. Zeros mean good things. It means we're divided. Look, we know, think about this. This x cubed, what is this huge polynomial? X cubed minus 2x squared minus 5x plus 6. We know that's equal to x squared plus x minus 2 times x minus 3, right? Because we can multiply that over. That's cool stuff. That's leading us into the next stuff, which is more important than really the division. Okay. Yay, I know the crowd goes, wow, this is so amazing. Yeah, these breakthroughs in mathematics. If you guys do decide to go into a business calc class, you're gonna be like, oh, I'm so glad he spent so much time on this section. If not, that's fine. Let's do one with a missing term, or maybe kind of one with a major missing term. 28. 28's got a lot of missing terms here. 28 says x to the 7th plus x to the 5th minus 10x cubed plus 12. Now we're dividing this all by x plus 2. Okay? X to the 7th plus x to the 5th minus 10x cubed plus 12. Now look, there's a lot of missing terms here. We're starting at x to the 7th, and every single integer degree going down has to have a spot. So remember the rules at the very beginning. Let's see if we can bring that slide back up. I don't know where I put it. Yes. Look at this fancy stuff right here. Look, the rule was it's got to be written in descending order with missing terms. So what that means, now this is in descending order, 7, 5, 3 constant, but we've got to insert the missing terms. So it'd be x to the 7th plus 0x to the 6th, because there's no x to the 6th term, plus x to the 5th plus 0x to the 4th minus 10x cubed plus 0x squared plus 0x plus 12. Holy cow. There's a lot of missing terms. This is an extreme example. All divided by x plus 2. Okay? So when I divide this synthetically, remember it's going to be a minus 2 there, right? Because it's x plus 2. And then I'm going to have a 1x to the 7th, 0x to the 6th, 1x to the 5th, 0x to the 4th, negative 10x cubed, 0x squared, 0x, and then a constant of 12. Whew. I might have bust a calculator out if this gets too. This is what it means by missing terms, okay? And we haven't had one. If you go back and look at the examples we've done so far, we haven't had an example that had a missing term. So I needed to do one with that. Okay, so let's look. If I bring down the 1, I get negative 2 plus 0, that's just negative 2. Multiply it, we get 4, positive 4, right? Plus 1, so we get a 5. It's negative 10. Negative 10 times negative 2, I get a positive 20. This would be a positive 10. Negative 20. Okay, this is when it's going to shoot off. Positive 40. They're all adding. 40 times negative 2 is at negative 80. Add that vertically. What's that? Is that 68? It's negative 68. Okay. Whew. Okay, so now what this means, though, remember this is our remainder, so it doesn't divide evenly. But now I've got to go all the way up here to see what's going on. Now I'm going to tell you a quick little trick here. It's all in the degrees. If you have a 7th degree polynomial and you're dividing it by a 1st degree, it's going to leave you with a 6th degree polynomial. Okay, like go back one example back over here. We had a 3rd degree polynomial divided by a 1st degree. You're really subtracting those. You wind up with a 2nd degree polynomial. Okay, kind of neat. It kind of whittles it down one at a time with the degree when we do this. But let's make sure. So we've got constant, remainder, constant, x squared, x cubed, x to the 4th, x to the 5th, and x to the 6th. So yes, we do start with a 1x to the 6th minus 2x to the 5th plus 5x to the 4th minus 10x cubed plus 10x squared minus 20x plus 40 plus, now you can write minus if you want here, but I always just do the remainder over the divisor. So I always put a plus. Okay, but you can say minus 68 over x plus 2 if you want. And that is our long solution. The entire page. Took the entire page left to right to write it. Crazy. I know. Okay. Questions, comments, concerns? We got this? Okay. So let's talk a little bit about the remainder theorem. Remainder theorem. All of this stuff ties together. Okay. The remainder theorem, which I believe is on, it's actually, I'll say remainder theorem / factor theorem, because I teach it together. Your book kind of separates it, but it's the same thing. Remainder factor theorem. So the remainder theorem says, look, if we're dividing some function by x minus c, okay? So again, this has to change the sign. Then it turns out, so if we're taking a function divided by, then f of c gives us the remainder. F of c gives us the remainder. So let's look at an example we've done already. Let's see here. Yeah, let's do this one. So let's look at this example right here. Okay, let's call this our function. So we've got some function, f of x equals 5x cubed minus 6x squared plus 3x plus 11. Okay, so we got this function. And we're going to divide it by x minus 2. Okay? Now, look, our goal really is just to see if this thing has a remainder of 0. So what you can do, actually, if it's x minus, you always change the number here, okay? Always, just like we did with synthetic division. So if we're going to divide this by x minus 2, we can just put in f of 2 into the function. So because we're dividing by x minus 2, f of 2 in the function, what we're going to see is we should get back 33. We should get back the remainder. Let's check. So 5 times 2 cubed minus 6 times 2 squared plus 3 times 2 plus 11. 2 cubed is 8, right? 8 times 5 is 40. 2 squared is 4 times a negative 6. That's negative 24. 3 times 2 is 6, and then plus 11. 40, let's just do all the positives here. 46 and 11. 46 plus 11, that's 57. Minus 24. Holy cow, look at that. 33. Now, of course, you can do this in the calculator. It takes you a lot less time, but it shows what this remainder theorem says. Look, we took a function, we divided it by x minus 2. We already did that up here, right? We divided by x minus 2. If we just want to plug in what the potential 0 is, it'll tell us the remainder. And this remainder means it's not a 0, right? You got to get back a 0 for it to be a 0. We know, we talked about that last time, right? If we get back a 0, it tells us that the number inside the function is a 0. That x value is a 0. Pretty cool, okay? I know, you don't have to tell me. It's pretty cool stuff. Yeah, so what happens if you get back a 0? This is the remainder theorem part. It says, like, look, if we get back a 0, then it turns out that this x minus 2 would actually be a factor. We know this already because I've talked about it extensively throughout the lecture, but that's fine. Let's do one and kind of show that. Let's see how they ask it in the book, actually. Okay, this is like 38. 38 says, use synthetic division and the remainder theorem to find the indicated function value. Okay, 38. We've got f of x equals x to the 4th minus 5x cubed plus 5x squared plus 5x, a lot of 5s, minus 6. Now, it says we're going to do f of 2. Okay, f of 2. So let's do f of 2 here. So I'm going to plug 2 in, and this is going to tell us really if 2 is a 0 or not, right? And because it's going to give us the remainder. So let's plug 2 in. So we get 2 to the 4th minus 5 times 2 cubed plus 5 times 2 squared plus 5 times 2 minus 6. So we wind up with 2 cubed, or 2 to the 4th is 16. This is 8 again times 5. Hey, minus 40. We did that earlier. 4 times 5, that's 20. Plus 10 minus 6. Again, I'm just going to add the positives up and then do the minus. So all the positive numbers, 30. Oh, that's not a positive number. What am I saying? 30 plus 16, that's 46. And then negative 40 minus 6, that's minus 46. Hey, this turns out to be 0. Okay? That turns out to be 0. Wow, that's cool. So what that means, because it's 0, x minus 2 is a factor of f of x. Okay, I don't want to write that all out again, but look, since I plugged 2 in, that tells me x minus 2 is a factor of f of x. Now, it also tells us to do the synthetic division. Let's do that just to get some practice in. So if I want to do the synthetic division, just to see what my quotient is, now remember, I'm going to put 2 here because 2 is the actual 0, okay? X minus 2 is the factor. Now I'm going to go back up here and pull the quotient out. So, or not the quotient, but the dividend. 1 minus 5, positive 5, positive 5, and minus 6. Okay? Bring the 1 down to negative 3, negative 6, negative 1, negative 2, 3, positive 6, and 0. I know I'm zooming through these. I've done them a lot. And you can like hit pause, catch up, and there's nothing wrong with that. But we've showed it both ways. So when we divide this out, the remaining factor is this quotient, right? So we can say now, this is what's really important. We can say now that this polynomial has a factor of x minus 2, right? Because it has a remainder of 0. And what we found here, what's left over. So now look, this is constant x squared, x cubed. So x cubed minus 3x squared minus x plus 3. Oh man, this is a big deal. This is a big deal, okay? Big deal. It really leads us to 3.4, which we're about to talk about. We're going to spend all day tomorrow on, okay? It's a big deal. Big deal. This is the goal. Okay? Okay. Questions? Okay, cool. Do a few more examples. We'll probably be done more early today. So I want you to look at your book now. And this is the like spoon-fed baby step examples getting us to 3.4. And it also brings in the whole, remember yesterday I was like, oh, we need to do one that's with the root solution and 0, how they all mean the same thing. It finally brings that up here. So let's look at number 42 first. It doesn't talk about roots or stuff yet, but we're about to. So 42 states, use synthetic division to divide f of x equals x cubed minus 2x squared minus x plus 2 by x plus 1. Now it says, use synthetic division to divide this by that, and then use the result to find all the zeros, okay? Use the result to find all the zeros. This is awesome, okay? This is actually what we've been trying to get to the last 2 lectures, okay? I'm going to divide this off first, right? It tells you to divide first. So we get 1, negative 2, negative 1, 2, right? 1, negative 2, negative 1, and 2. This has to divide evenly, or we can't get to the remaining zeros. Now remember, if we have a 3rd degree polynomial, we're going to have 3 zeros. Now we might have repeating zeros, but we're going to have 3 zeros, right? So I'm going to bring down the 1, negative 1, negative 3, positive 3, positive 2, negative 2, 0. Okay, I'm trying to make it more entertaining. Bam. That's what we needed. We needed a 0, and that tells us a lot, right? What this tells us actually is that -1 is a 0 because we have, remember, if we plug this into the equation, we're going to get back the remainder, right? So we plug this in, that was what the remainder theorem is that we just talked about. So what this tells me is if I plug f of -1 in, I get back 0. So -1 is one of my 3 zeros, right? What this also means is that this third degree polynomial has a factor of x plus 1, right? And the quotient here is the other factor. So now look, constant x squared. So x squared minus 3x plus 2. Okay. Okay. I don't know if you ever watched the show New Girl. Have we talked about New Girl before? Okay. In New Girl, there's a game they play, and we all played it probably. We might still play it, where the floor is lava, okay? And we have to get to our safety couch. Okay, quadratics are our safety couch. We know how to solve quadratics. We've done it over and over again. We did it in developmental 2 or intermediate. We did it at the beginning of this class. And now we're really using it to finish out solving polynomials, okay? We want to get a polynomial. This is a third degree polynomial, right? It's not a quadratic. We want to divide it out until we can get it into a quadratic because I know how to solve quadratics. Now for this one, I'm going to factor it. If I didn't know how to factor, or if I didn't know how to factor, if it didn't factor, we'd have to solve it with like the quadratic equation to find the last 2 solutions, okay? But let's factor this one. This one should factor pretty easy. This is what, -1 minus 2, right? Multiplies to give me the positive 2, adds to give me the -3. There we go. Boom. There's our 3 zeros. So we've got x equals -1 from the first factor. Remember, it's got a multiplicity of 1. That was in the last lecture. X equals +1, still a multiplicity of 1. And x equals +2. Again, a multiplicity of 1. Hey, 3 solutions. Third degree polynomial, not a coincidence at all, okay? Now let's do a quick sketch. We did this at the end of the last lecture, and this is really just to bring up topics from the last lecture. We've got zeros. Now remember, if we have real zeros, that means they're x-intercepts, right? So -1, it's another color. Ooh. You know what? It's after October 31st. Time to bring in some Christmas colors. Let's do red and green here. +1, +2. We know those are our 3 zeros because that's our, or 3 intercepts because those are from the 0. Now, we know the end behavior of this thing, right? It's got a positive leading coefficient. So I know that this is going to be going up. It's odd degree, so I know this has to be going down. I know the y-intercept. Remember, the y-intercept's always your constant over here. I know that's my y-intercept. And I know the multiplicities on all these are just 1. So they're not going to touch. They're not going to bounce, right? They're going to go through. So it looks something like this. I mean, it's not perfect. It looks something like that. Something like that, okay? Now, your book didn't ask you to do that. That's just bringing in stuff from the last lecture, okay? Cross-merchandising if you work in retail. Okay. Questions? This is bringing it all together. I'll tell you in 3.4, what's going to happen is I'm just going to give you a polynomial and you're going to have to solve it. Okay. So they're spoon feeding it a little to you because they're saying, hey, divide it by this number and then solve it, right? We're going to get to a point where we're going to start here and you're going to have to figure out what to divide it by. We'll look at techniques in 3.4 to do that. But once you know what to divide by, it's all easy because we've done it in 3.3. Okay, let's look at another one. Let's do now one with the root aspect or this is like 40. Where was it? Solve the equation. Yeah, no. Let's do 46. Oh, yeah, this one's not fun looking. 3x cubed plus 7x squared minus 22x minus 8 equals 0. Now notice they start with an equation here. And it says solve the equation given negative 1/3 is a root. Okay, so I chose this one because it uses different terminology. That's honestly it. Okay. And the reason they're calling it a root and not a 0 is because we started with an equation and not a function. But I'm going to think of this as a function. Okay, I like just automatically switching it over to f of x equals 3x cubed plus 7x squared minus 22x minus 8. And what we know actually is x equals negative 1/3 is a 0. So these two things mean the exact same, okay? F of x is this function, or this equation right here to the left of 0. That's my function. And I know because negative 1/3 is a root, what that really means is x equals negative 1/3 is a 0. And again, because we got a third degree to kind of assess what's going on here. We've got a third degree polynomial. We know we have 3 zeros. We know one of them already, okay? If that's a 0, we should be able to divide it out of here evenly. So let's do that. Now look, negative 1/3 is the 0. So that's what goes right here. And I know you're thinking, but Mr. Sherman, you changed the sign on all the other ones. And it's because if you look back, we changed the sign whenever it was a factor. If it was x plus 1/3, actually, this is the factor it comes from. It would be a negative 1/3 here, but we changed the sign. But it tells us the 0 already, okay? So let's do the descending order. We've got all the terms here, right? Cubed, squared, x, yeah. The gang's all here. Okay, bring the 3 down. 3 times a third. Oh, that's just 1, right? A third of 3 is 1. Now it's negative. So negative 1. Add vertically, we get 6. 6 times a third, well, that's 2, right? So it's negative though, negative 2. So we get negative 24. Well, a third of 24 is 8, right? Negative makes it a positive. Yes. Okay. Another smiling 0. And we knew this would, if this didn't happen for this, you did the math wrong, okay? Because they told you it was a 0 or the book messed up. And I'll tell you, it's in like the 6th edition for this book. So they've caught a lot of those kind of goofy mistakes. But so if you did one wrong where they gave you the 0, you probably did the math wrong here, okay? So what does it tell us though? It tells us that f of x equals, now we know if minus 1/3 is the solution or the root or the 0, that x plus 1/3 is the factor. Get 3x squared plus 6x minus 24, okay? Now our goal is to find the last 2 zeros here, right? Again, we're in our safety zone. Boom, this is a quadratic. We've hit the safety couch, okay? Now I've got to solve this out. Now I want you to notice something because this is nice when it happens. It doesn't happen a lot. But look, notice 3, 6, and 24 are all divisible by 3, right? We can factor that out. 3 turns out to be a factor. It doesn't matter because it doesn't have an x. But I'll show you how to write it. So if I can factor 3 out. Now look, this is all multiplication here. Oop, that's an x. I don't know why I started writing 3. I put the 3 at the very beginning because it's a constant. And we're left with x squared plus 2x minus 8. Okay, so if you notice one of the factors has a term or something that is as a factor inside of each, what is the word I'm going for? If you notice one of the factors has a common factor inside, you can factor it out and just put it at the very beginning. Okay, and that's a notation thing. You can put it in between if you want, but if it's just a single factor, you just put it at the very beginning. Okay, now this factors easily, actually, just like before. 3x plus 1/3. This is what? Plus 4 minus 2. Multiplies to give me -8. Adds to give me a +2. And boom, shakalaka. There's our 3 zeros. So x equals -1/3, which we knew already. X equals -4. And lastly, x equals +2. Now that's what they asked for. I'm going to go through the whole graphing thing just to bring it back up from yesterday to show you how it all comes together here. So 1, 2, 3, 4. 1, 2. What's -8? Our y intercept's way down here somewhere. Okay. So what matters here, though, is the zeros are -1, 4, or -4, -1/3, which is about right there, and a +2. And it's got the same end behavior as before. So this would be up, and this is going to be down. So it winds up going really, now look, this is really high up, like it's really, goes up really high. And then it slants down really, I mean, this goes down to -8, right? So I know this isn't right at all. But it's a nice rough sketch of a graph. Okay. Okay. We are done. Let's look at homework. So I'm just gonna instead of killing a whole other piece of paper, use this one. It's not. So for homework, I want you to start on page 374, actually. Page 374. Number 9 through, oh, wait, not number 9, 11. Number 17 through 49 odd. 17 through 49 odd. And I need you to at least look at these and work through them before you get to the next lecture. So I need, like tonight, I need you, if you're coming tomorrow, I need you to look at these and get them done for tomorrow. Because I need you to ask questions. Now, if you're watching this later, just get this homework done before you start the next video for the next homework, okay? And now, hold on real quick before we kind of finish up here. You know, I think the next test is Thursday, right? Let me get on this real fast. I want to just kind of tell you what's, so we don't get blindsided by it. Because I think we've got Thursday tests from here on out. I'm going into the Blackboard shell. If I go into the schedule, we are in, yeah, we're in week 4. I mean, we're at the midway point, right? Actually, we're past the midway point. So yeah, this Thursday is going to be test 3. So tomorrow I'm going to go over 3.4, and then the test will be, and I'll open it actually after 3.4, and the test will be open until Sunday. Okay. So no big deal. Questions about that? Okay. So we'll